Hello dear students, hope you have been taking these online classes seriously. We have already completed chapter 2 in our previous video. Today we are going to start with chapter 3 and that is water. Okay, now this is for class 9. As you know, water is the most important natural resource without which the life on earth would not be possible. Okay, so the surface of earth is almost occupied by water. What is the percentage of water? It is 70%. See, earth's area occupied by water is how much? 70%, out of which only 2.5% are supply of fresh water, means which are drinkable water. That is only 2.5%. And our body as a whole is made up of almost 70% of water. So such is the usefulness of water in our everyday life and for the existence and sustenance of human beings as well as plants and animals. So today we are going to discuss in more detail about water. So chemical formula of water, you already know it is H2O. Now let's discuss some of the physical properties of water. Okay? Physical properties of water. Physical properties of water. The first one we are going to discuss about is nature of water. You have seen clean water. Clean water is what? Transparent, and they are colorless as well as odorless, and they do not taste. That is tasteless. So nature of water is what? It is colorless, odorless. Odorless means no smell. Water doesn't have any, clear water doesn't have any odor, means no smell. And it is also colorless, odorless and tasteless. Now, the second property is, let's discuss about its boiling point. As you know, the boiling point of water at normal atmospheric pressure, that is 1 atmosphere, is 100 degrees centigrade. So boiling point of water is 100 degree centigrade. Now this boiling point can be changed by two factors. Okay, one is pressure, the other one is pressure. The second factor is impurities dissolved. So I told you boiling point of water at normal atmospheric pressure, that is 1 atmosphere, is 100 degrees Celsius. Now this boiling point varies when pressure is changed and as well as when some impurities are added. Now whenever we increase the pressure, what will happen? The boiling point will also increase. Okay? So as you increase pressure, it increases boiling point of water. Now whenever we have some impurities dissolved in water, then that will also lead to increase in boiling point of water. So both of these factors, that is pressure and impurities, they increase the boiling point of water. Now see, this pressure, whenever it is increased, what happens? The boiling point also increases. Now this principle is used at high altitudes. You know, as you go up, okay, at higher altitude, the pressure keeps on decreasing. Now if the pressure decreases, means its boiling point will also decrease. Water's boiling point will also decrease. Now for example, at the top of Mount Everest, water boils at 70 degrees centigrade. Now you think a person is cooking food at 70 degrees centigrade, means it won't be cooked properly. Okay, now this makes the pressure cooker so important for cooking at higher altitudes. Now what happens inside the pressure cooker? The pressure is different from atmospheric pressure. The pressure inside the pressure cooker will be increased. As a result, water now will boil at higher temperature. Now as a result of that, what will happen? The food now gets cooked properly once it is cooked in pressure cooker. Hope this is clear. Now impurities also increases the boiling point of water. Now let's discuss the third property, that is freezing point. The third one is freezing point. As you already know, water freezes at 0 degree centigrade. Okay? At what temperature? Liquid water converts into ice at 0 degree centigrade. Now here also pressure and impurities, they affect the freezing point of water. Now here it's just the reverse of boiling point. Here pressure, as you increase the pressure, as pressure increases, what will happen to the freezing point? Freezing point, this FP means freezing point, and in short form, decreases. And also the impurities dissolve. Impurities decreases the freezing point of water. Okay, so this is just the opposite. Pressure and this dissolving impurities. Here, in case of freezing point, it's just the opposite of it was in boiling point of water. Okay. Now the next topic is density. That means next topic I mean to say the fourth physical property of water. Density. At 4 degrees centigrade, please remember this one. At 4 degrees centigrade, water has the maximum density. Okay? Remember this one? And if density is maximum at 4 degrees centigrade, then its volume would be least. Means the least volume, because density and volume, they are inversely proportional to each other. If one increases, the other one has to go down. If one increases, the other one decreases. Okay? Now, the fifth point is very important, and please listen to it carefully. We know that as we keep on decreasing the temperature, what will happen to the volume? Volume will keep on decreasing. Okay? So the fifth point is anomalous behavior of or expansion of water. Now please listen to it very carefully. As water is cooled, what will happen? It shows some unusual physical property. It shows what? Some unusual physical property. And what is that? Listen to it very carefully. When cooled, it first contracts in volume. Means as you are cooling water at higher degree centigrade to lower degree centigrade, the volume of water keeps on contracting. Means the volume gets smaller and smaller. Till what point? Till 4 degrees centigrade. Now at 4 degrees centigrade, till 4 degrees centigrade, the volume of water keeps on decreasing. Now once it crosses below 4 degrees centigrade, then what will happen? Water will start expanding now. Please listen to it very carefully. Below 4 degrees centigrade, what will happen to the water? Now water will keep on expanding, okay, and it keeps on expanding till it reaches its freezing point, that is 0 degrees centigrade. Hope this is clear. So below 4 degrees centigrade, what will happen to water? Instead of, like other liquids, instead of contracting, it expands from 4 degrees centigrade to 0 degrees centigrade. Now this property is so important for the existence of marine life in cold countries. You know, in cold countries, most of the time the atmospheric temperature is below 0 degrees centigrade. Yes or no? So what happens over there? The surface of water gets what? It gets freezed. As a result, what will happen? So, as a property, which property? Anomalous expansion of water. What will happen? Suppose this is water present here. Now we are talking about cold countries, okay, where the temperature is extremely low. What will happen? As the temperature outside is 0 degrees centigrade, then what will happen? Water at the surface will freeze. Water at the surface will freeze. This is ice. Now, the water below this layer of ice will be still in liquid state. Okay? It will be still in liquid state. Why? Because now once it freezes, the surface of water freezes, what will happen? It will, since it is a bad conductor of heat, it won't let the inside portion to be affected by outside temperature, that is very, very low. Therefore, now here water will be around 1 degree centigrade or 2 degrees centigrade, okay, and they are still in the liquid state, and this makes life possible where in cold countries. The marine life is possible because of this phenomenon. Hope this is clear. Please refer to your book for better or more understanding. Now the next topic or the next property that we have is latent heat of fusion of ice. This is the sixth property, latent heat of fusion of ice. Now, what is this latent heat? It has to be related with what? Energy. So, what is latent heat of fusion of ice? It is the amount of heat energy, okay, required by ice to change into liquid water. So let me repeat it once again. It is the amount of heat required by ice to get converted itself into liquid water which will be in 0 degrees centigrade. Okay, so the amount of heat that is required, see here the conversion is from ice to water, and the heat energy required here is how much? It is 336 joule per gram, or in another unit it is 80 calorie per gram. Okay, so this was about latent heat of fusion of ice. The next topic is latent heat of vaporizers. So now we are discussing about latent heat of vaporization. So whenever I say vaporization, what comes in your mind? The gaseous state. So here what happens is, now it is here the conversion will be from water to vapor. So at what temperature water boils? Pure water boils at 100 degrees centigrade. So now listen to the definition of latent heat of vaporization of water. It is the amount of heat energy required to change water into its vapor. So water being converted into vapor, how much heat energy is required? And the temperature has to be at what? It has to be at boiling point. Okay? It has to be at boiling point, and there should not be change in any temperature. Okay? So at 100 degrees centigrade, the amount of heat required to change water into water vapor is known as what? Latent heat of vaporization. And it is how much? It is 2268, means 2268 joule per gram, or it is 540 calorie per gram. So this much of heat is required. Okay. Now let's discuss about the next topic, that is specific heat capacity. The next topic is what? Specific heat capacity. And this is the eighth property. Specific heat capacity. So what is specific heat capacity? It is the heat absorbed by 1 gram of water when heated through 1 degree centigrade. So here we are talking about 1 gram of water when heating it, so that its temperature, now temperature rises by 1 degree centigrade. How much? 1 degree centigrade. So the amount of heat required or absorbed by water, how much water? 1 gram. Please don't forget, 1 gram. To raise the temperature by how much? 1 degree centigrade. So that much heat is known as the specific heat capacity of water. And the value is 4.2 joule. So the specific heat capacity of water is how much? 4.2 joule. Hope this is clear. These were the 8 physical properties of water. Now you know water dissolves so many substances. Okay? Whenever it is put into water, not only just the solids, but also the liquids and also gases. You know, gases even gets dissolved in water. Now, since so many different states of matter gets dissolved into water, now here water is acting as what? Solvent. And since it is dissolved in so many compounds, which includes, let me tell you once again, solids, liquids as well as gases, Therefore, it is known as what? Universal solvent. It is known as what? Universal solvent. So water is also known as what? Universal solvent. Why? Because most of the substances, it may be solid, liquid or gases, they get dissolved in water. Because of that, water is known as what? Universal solvent. Now since we talked about solids being dissolved in water, now you know even the salts get dissolved in water. Now what is the importance of these salts which are dissolved in water? Let's discuss that, okay? Importance of salts dissolved in water. So, you know, the first importance is for plants. Now, these dissolved minerals in the form of salts, they are very essential for growth and development of the plants. So it is essential for growth and development of plants. The second one, you already know it. It adds taste to water, yes or no? Now, these dissolved salts will add taste to water. The third one is what? Even our body needs minerals for proper functioning. Now, these salts which are dissolved in water are also essential for our body. Now, these salts are also essential for our bodies. It supplies essential minerals to our body. So these were the three main importance of salts dissolved in water. Now, we talked about gases being dissolved in water. Yes or no? You know, oxygen gas gets dissolved in water, carbon dioxide and many other gases. So now let's discuss about the importance of these gases which are dissolved in water for our animal as well as plants life. Importance of gases dissolved in water. Dissolved in water. Now, see, oxygen gas is dissolved in water. Yes or no? Therefore, this dissolved oxygen are very essential for marine life, like fish. You know, fish doesn't come out of water. Now, it needs oxygen for respiration. Now, this oxygen, it gets it from dissolved water. Okay? So, the first one is marine life, like fish, uses what? Dissolved oxygen for respiration. This is the first importance for respiration of marine life. The second one is for photosynthesis. Now, water also contains what? Dissolved carbon dioxide. Now, this dissolved carbon dioxide will be utilized by aquatic plants. For what? For photosynthesis. Now, this is the process from where these plants, they make their own food. Okay? Now, this dissolved carbon dioxide okay, is used in the process of photosynthesis. It gives you what? Glucose. 6H12O6 plus oxygen. So we have discussed about this reaction before also. So 6 carbon, 6 water molecule, and here also 6 oxygen. So two main importance. Now one more importance is that, like you have seen snails, oysters, they have protective cell upon them. Now this is also from where it gets it. The dissolved carbon dioxide will react with limestone. Okay, let me write that reaction. Number 3. The number 3 is what? I told you. This dissolved carbon dioxide, okay, in water will react with limestone present in water. Limestone. Okay, limestone is what? Calcium carbonate. So what will happen when this carbon dioxide reacts with calcium carbonate? Then it forms calcium bicarbonate as CO3. Okay. Now this calcium bicarbonate, it has to be 2 here because the valency of calcium is 2. Now this dissolved bicarbonate, this is what? Calcium bicarbonate. This is bicarbonate, and in front what you have? Calcium. So it is calcium bicarbonate. Now the snails and the oysters, they use this calcium bicarbonate for making up of their cells. Okay, so this were the importance of gas dissolving water. Now this was for today. Your assignment, please take it seriously. Your assignment will be to solve exercise 3A. Okay, so we'll be seeing you in the next video. Till then, take care.